Help with Circles Part 2, looking at arcs and central angles. Keys in this section. First of all, the degrees around a circle, as some of you already know, are 360 degrees. If you go all the way around in a circle, you've traveled 360 degrees. Some people say if you do a 360, you go all the way around and end up where you were. A semicircle, semi meaning half, would obviously equal 180 degrees. So if we go halfway around the circle, we've traveled 180 degrees. Again, sometimes people use that phrase to say you did a 180 or went from one place halfway around to the other side. Key thing. Central angles is an angle whose vertex is at the center of a circle. That's what a central angle. And an arc is a piece of a circle. This right here is an arc. This is part of the circle. So an arc is curved, and we'll see in a minute that when we name an arc, we just make this little curve. So an arc is a piece of a circle. A central angle is an angle that's vertex lands in the middle of the circle. When we create a central angle, we create an arc that goes with it. And what this says right here is that we can measure those both in degrees. So sometimes we will go, here's my central angle, here's another central angle. And if I want to look at the example number 1, it says how long is this arc in degrees? Then what we do is we look at the central angle. So if we go back where we were before, we can name this circle. This is circle X. It has 3 radii, XW, XY, XZ. And it has one diameter, YZ. Now, if we want to find, the question says find the measure of the arc in degrees. That's kind of cut off, I apologize. Then we look at the arc. Which arc are they talking about? WZ is the name of the arc. To name an arc, we use the symbol. Again, in geometry, we're consistent. Our symbols will look like our pictures. So to name an arc, we put a little arc over the letters that are involved. So if we're looking at WZ, we call it arc WZ, and we say that's 120. The central angle is 120, the arc is 120. This is in degrees. We're going to look at later arc lengths, and we're going to do something a little differently. But right now we're talking about what are the degrees measures of the central angle and the arc, and the key right here is that says they're both. So the central angle is y, whoops. If we look at this other central angle here, yxw, we could find out how big that angle is too, because up here it tells us this is a semicircle. So if this is 120, then we know 60 is this other angle, because 120 plus 60 is the 180. And this arc here, YW, would also be 60. So the central angle and the arc are the same measure. We look over here, this angle is 90 degrees, then this arc is 90 degrees. So the central angle is angle AYB is 90 degrees, and arc AB is also 90 degrees. Pretty simple, straightforward. There's 3 types of classifications of arcs. We have minor arcs, major arcs, and a semicircle. As I said at the top of this page, a semicircle means half a circle. So a semicircle is 180 degrees. So if we look at an arc that's 180 degrees and we're asked to classify it, if we were asked, what kind of arc is this one right here, YZ, we would choose semicircle. A minor arc is an arc that is less than 180 degrees or less than half of the circle. And when we name it, we use 2 letters as we saw above. So up here we said YW is a minor arc. We use 2 letters. WZ is a minor arc. Both of those are less than halfway around the circle. And a major arc is more than halfway around. And when we go more than halfway around, we use 3 letters to name our arc. So up here, we only dealt with minor arcs. And you see 1, 2, 3. places where we name the arcs, we only use 2 letters. Now, when we go down here, we'll look at major and minor arcs. Number 7 and 8, name the arc made by the given angle. So this angle is angle UQV. My circle is circle Q. I have 2 radii in here. The radii make up the arc. And the minor arc that's created there is UV. Now, if I want to name the major arc, which is the one that goes the rest of the way around the circle, goes more than halfway around, then we use 3 letters. The middle letter is the middle point or the in-between point when we go around. So we could either name it VWU or UWV. When we use 3 letters, we're usually naming a major arc, which is more than halfway around the circle. Apply that again over here. Minor arc, HI. Major arc, IJH. Again, don't leave out your arc symbol. Use 2 letters for a minor arc. Use 3 letters for a major arc. Starting and ending point and 1 point in the middle. Notice we didn't start with J here. Notice we didn't start with W there. There we are again, naming the central angle. So we have an arc, and it says name the central angle. So remember, when we name a central angle, we use this symbol here, our angle symbol, and we make sure the key to the name of the angle is that the vertex, and we're naming a central angle, the vertex of the center circle, is in the middle of the name. Angle Q, angle Q. So this is angle GQH, or if you want it, HQG. We're looking at arc BC. So this is angle BQC. The cool thing about this is that when we're looking at an arc and we're going to name the angle, we use the arc letters and put the center of the circle in the middle. HQG is another name to name this angle. BQC is another name to name that central angle. Last concept, to find arc length. An arc length is part of the circumference. If I look at this, my circumference we said was all the way around, and arc length only goes part way around. So to do that, we have to find our circumference, and then we create this little fraction right here, which represents the fraction of the circle that is cut by the arc or the angle. So what we do is we take the degrees of whatever angle or arc we're using, and we put it over 360, because 360 is the whole circle. So if I apply that here, number 11, the angle is 90. So my fraction is 90 over 360. Now, first thing I got to do is find my circumference of the whole circle. So I got my radius, I need my diameter, and the circumference of the whole circle is going to be 24 times pi. The diameter is 24 multiplied by pi. Now, to find the length of the arc, we're going to take this and multiply by this. Take our fraction times our circumference. So we've got 1/4 times 24 pi, and 1/4 of 24 is 6 pi. And if we use our calculator, it's about 18.84. Another example, let's create our circumference. We've got to double our radius because we got a radius here. So the radius is 34, circumference is 34. Create our fraction. 60 over 160 reduces to 1/6. So our arc length is going to be 1/6 times 34 pi, which is 34 pi over 6. I can divide both of these by 2, reduce it to this. If I want to get my decimal approximation, notice I get my approximate signs here, I'm going to take 3.14, multiply by 17, then divide by 3. That's where I got this. And one more. This is a bigger piece of the circle. First, find our circumference. We've got a radius of 11, diameter is 22, circumference is 22 pi. Create our fraction, 270 over 360. Divide these both by 90, 3/4. This times this, 3/4 times 22 pi. 3 times 22 is 66 pi over 4. Divide them both by 2, 33 pi over 2. Now, if you're getting a decimal answer, you do not have to reduce it. Remember, this is an exact answer. If they say, give us the exact answer, don't plug anything in for pi. Leave the pi right there. Don't create extra work. If it says, give an approximate answer, then we're going to plug it in. Hope that helps.